Okay, welcome to section 5.5. And in this section, we're going to look at differentiating and integrating functions with base, exponential and log functions with bases other than e. And like what we found in most of this section is that it's just memorizing formulas, really. So here are two formulas for you to know. A needs to be a constant, so it's like 1, 3, 7, any constant in both of these. A just has to be a constant. Okay, so to do this, we're going to use quotient rule and the rule that we just learned. We're going to use this one, where A is 3. Okay, so quotient rule, low times the derivative of the high. Well, the first thing we have to do is take the derivative of 2t, which is 2, and then we take the derivative of 3 to the u, which is the natural log of 3 times 3 to the 2t. Okay? So that's low times the derivative of high minus high, so of course this just stays the same, times the derivative of the low, which is 1 all over low squared. And that's pretty much it. We could probably make that prettier, maybe take out 3 to the 2t, and then that'll leave us with 2t, natural log of 3 minus 1 over t squared. We could do that if we were so inclined. Don't have to. All right, so this one, we're going to use the formula that we just learned for log, taking the derivative with the log. So that's basically 1 over the natural log of 5 times our function, which is x square root of x minus 1 over 2, and then times the derivative of all of this. So to find the derivative of all this, we're going to have to use, I'm going to use product rule. So we keep x the same. We take the derivative of this, which is 1 over 2, square root of x minus 1. So I keep that the same. I took the derivative of that, plus the derivative of x is 1, and keeping x minus 1. And that ugly thing is actually the derivative. It's pretty ugly, I know. And there's nothing that we're going to do to that. Leave that alone. Find the equation of the line tangent at the given point. So once again, we have to just find the derivative. So y prime will equal to the natural log of 5 times 5 to the x minus 2 times the derivative of x minus 2, which is just 1. So that's the natural log of that. So y prime of 2 is going to be the natural log of 5 times 2 minus 2 is 0. So times 5 to the 0, which is simply the natural log of 5. So the equation of the line would be y minus 1 equals natural log of 5, x minus 2. Okay, so we have to use logarithmic differentiation for this. And you'll see that logarithmic differentiation is really important when we get to L'Hopital's rule. So to take the logarithmic differentiation, and one of the reasons I have to use logarithmic differentiation and not what we've done before is because this is not a constant. So I can only use what we've done in the past, like a to the x, if this were a constant. So this isn't a constant, okay? So then I'm going to have to do the natural log of y is equal to, taking the natural log of this, I get 1 over x, natural log of 1 plus x. So now, once I have this, I'm going to take the derivative of both sides, and I have to use implicit now. So the derivative of natural log of y is 1 over y. The derivative of y is just y prime. And to take the derivative of this, I'm going to have to use, I can either use product rule or quotient rule, and I'm going to choose to use quotient rule, because I can write this as the natural log of 1 plus x over x. So I'm going to choose to use quotient rule. So I have the low times the derivative of high, which is 1 over 1 plus x, times the derivative of that, which is simply times the derivative of this inside, which is simply 1. So low times the derivative of high minus high times the derivative of the low, which is 1, all over low squared. Okay, so cleaning that up, if you will, I get y over y prime is equal to x over 1 plus x minus the natural log of 1 plus x all over x squared. And I don't know why I wrote that like that. That's y prime over y. I wrote it that way. This is y prime over y. So then y prime is equal to, could I clean this up a little bit? Yeah, let's clean that up a little bit. I get x minus 1 plus x, the natural log of 1 plus x, all over x squared times 1 plus x. And I have to multiply all of that times y. But remember, y in this case was what I started with. So it's 1 plus x raised to the 1 over x. There's a lot on that problem. It's ugly, but that's what we would call simplified. Find the equation of the tangent line at the given point. We're going to do the same thing. We're going to have to use logarithmic differentiation to find the derivative of this. So that's going to be, I'm going to take natural log of both sides. So I get the natural log of y is equal to times x times the natural log of sine x. Taking the derivative, I get y prime over y is equal to, and I'm going to use product rule again, well, this time product rule. So I get 2x times the natural log of sine over x, which would be, take the derivative of the inside, cosine x, over sine x, plus, now keep this the same and take the derivative of 2x, which is just 2 natural log sine x. Okay, and then to get y prime, it's y prime is equal to 2 to the x cosine x sine x plus 2 natural log sine x. And I am not going to write out the value of y here. And the reason I don't write out the value of y, because I'm evaluating this at this point. And at this point, y is 1. So I don't have to go through and evaluate it. I already know what it is. So I'm just going to simply, every place I see x, replace it with pi over 2. And where I see y, I'm going to replace it with 1. So that gives me y prime is equal to 2 times pi over 2 is simply pi. Cosine of pi, well, it's actually the tangent of pi over 2, or the cotangent. Cosine of pi over 2 is 0. So that's just going to be 0 plus 2 times the natural log of sine of pi over 2 is 1. So that's the natural log of 1 times y, which is 1. But the natural log of 1 is 0, so I have 0 plus 0, so this is just y prime is 0. So I get y minus 1 is equal to 0 times x minus pi over 2. Then it would just y equals to 1. Seems like a waste for such a nice problem as that, but that's what I get. Okay, so now let's look at bases integrated with bases other than e, and this is our formula. Okay, so we are going to have to use a u substitution here. So if we let u equal to negative x, then du is equal to negative dx. Basically, all I'm doing is taking out a negative from this and integrating 5 to the u, du. And using the formula that we just learned, that's going to be 1 over the natural log of 5 times 5 to the negative 1. So 1 over the natural log of 5 times 5 to the u. In this case, that would be negative x. And the whole thing is negative plus c. Okay, so in this one, once again, I'm going to have to use the u substitution. So I'm going to let u equal to 3 minus x quantity squared, which gives me du is equal to 2, 3 minus x, and then I still have to use chain rule on that, negative 1 dx. Okay? So I have 3 minus x, so I have to take out the negative 1/2. So this gives me negative 1/2, the integral of 7u du. And again, that is 1 over the natural log of 7. What is that formula? 1 over the natural log of 7 times, let me look at that formula again. Yes, you need to know the formula, and I need to learn the formula too, yes. 1 over the natural log of a, so in this case 1 over the natural log of 7, times 7 to the u. In this case, u is 3 minus x squared. There we go. Okay, so basically, we don't even have to use u substitution on these. So this is 1 over the natural log of 6. Ooh, 6 looks like 2 now. That's new math. 1 over the natural log of 6 times 6 to the x minus 1 over the natural log of 2 times 2 to the x. And I'm evaluating that from 1 to e. So that gives me 6 to the e over the natural log of 6 minus, that should be 2 to the e over the natural log of 2 minus 6 over the natural log of 6 minus 2 over the natural log of 2. And that's really my answer. Find the area of the region 3 cosine x sine x bounded by 0, x equals 0 and x equals pi. Okay, so this really is a chapter 6 problem, but we can do it. So the integral is simply going to be the integral from 0 to pi, 3 cosine x sine x. So we're going to have to do a u substitution. So we let u equal to cosine x. So du is equal to negative sine x. Let's change our limits. So u of pi, the cosine of pi is negative 1, and u of 0 is, cosine of 0 is 1. Okay, so notice all these negatives. Let's do a property to get rid of the negatives, but for now I'm going to write it as negative. Then it'll go from 1 to negative 1 of 3 to the u du. Okay, so this is negative and these are swapped. So what if I switch these around? So I make negative 1 to 1, and because I flipped these around, I got rid of the negative, and it's still 3 to the u du. So that gives me 1 over the natural log of 3 to the u, evaluated from negative 1 to 1. So that is 3 over the natural log of 3 minus 1/3 over the natural log of 3. And that's pretty much it. And this became 1/3 because 3 to the negative 1 can be written as 1 over 3. Okay, is that it? That is it for this section. We'll see you at the next video.